So in our last video, we practiced doing some more complicated redox half equations using our important 3 rules. Okay, we use those for writing out our half equations. So what we are going to do now is, we did say that a half equation cannot happen by itself. A reaction will only happen if one reactant gives away electrons, so the electrons are on the right hand side, and these are the electrons that are accepted by the other reactant, and the electrons are going to be on the left hand side of the equation, half equation. When you're putting 2 half equations together, the first thing you need to be very, very careful about is, have I got one reactant that is being oxidized, electrons on this side, and have I got the other reactant being reduced, electrons on this side? Okay, I cannot put 2 half equations together which it shows both substances being oxidized or both substances being reduced. That's wrong. Okay, so how am I going to put these 2 half equations together to come up with the overall balanced ionic equation between MnO4 minus and Fe2 plus? Now the first thing that you have to notice is, that in this half equation, Fe2 plus ions are losing 1 electron, but MnO4 minus ions need to gain 5 electrons. So what does this mean? For every 1 MnO4 minus reacting, how many Fe2 plus must there be so that the Fe2 plus can actually give 5 electrons? I have to have 5 Fe2 plus. So I will multiply all of this half equation by 5. Okay, so what would I end up with? Let me just take it down and put it over here. I would end up with 5 Fe2 plus becoming 5 Fe3 plus 5 electrons. So now we're going to be comparing these. Have I got the same number of electrons being lost and gained? Yes, I have. So we can cross those off and just now put all the reactants together. What are all the reactants? MnO4 minus plus 8H plus the reactants from the other half equation. And what are they going to become? The products from both half equations. So what is that going to be? Mn2 plus 4H2O 5 Fe3 plus, and that's your overall balanced redox ionic equation. Okay, so let's have a look. Can we apply this again now using still the same one here? Cover it up, I think. With how does MnO4 minus react with hydrogen peroxide? So let's have a look here. Let me just modify. If you remember, each MnO4 minus needed to gain 5 electrons. So MnO4 minus can react now with hydrogen peroxide, giving you oxygen, hydrogen ions and 2 electrons. I'm just going to rub that off here and write it up a bit better here. So what did we have? H2O2 becoming oxygen, need to balance with the hydrogen ions and the 2 electrons. So I have a problem here because each hydrogen peroxide gives away 2 electrons. Each MnO4 minus gains 5 electrons. So what's a common factor numerically between 5 and 2? I have to try and make everything up to 10. So what am I going to do here? I'm going to have to multiply this half equation, all of it, times 10. And all of this half equation by what? All of it by 2. Sometimes it gets a little bit complicated. So let's multiply this one out by 2 first of all. So what have I got? 2MnO4 minus plus 16H plus becomes 2Mn2 plus and 2 4s are 8H2O. And remember, how many electrons on this side? 10 electrons. Now let's do the same with this one. What have I got to multiply this by? Times 5. Sorry, to make 10. Because why? 5 times 2 is 10. So 5 H2O2, 5 oxygens, 5 times 2, 10 H plus, and 10 electrons. So can we see anything now in my 2 half equations? I still haven't put them together that are the same on both sides. Well, definitely if you've done it correctly, my electrons should cancel out. 10 electrons lost, 10 electrons gained. But there is something else that you could also cancel out. Can you see what it is? It's actually H plus ions. I can simplify it. I can get rid of the 10 H plus ions. 10 H plus ions. So how many H plus ions would you have left over? 6 H plus. Okay. So now I can put all the reactants together, all the products together. So what would we end up with? 2MnO4 minus, 6H plus, 5H2O2, all the products, 2Mn2 plus, 8H2O, 5 oxygens. At the moment it might look like a long way of doing this balancing, but if you didn't do it this way it would be incredibly difficult and you'd be there for hours trying to balance the redox equations.